Hi, this is Margaret, and welcome to Mechanical Design Skills. So, when you think about the idea of mechanical design, I'm not sure what you're picturing. If you tried to go find a book about how to do mechanical design, as I have spent a lot of time doing, you will discover, oh wait, there actually isn't one. There are a lot of engineering books that talk about how to do engineering calculations, and there are books about specific subjects. And here's the thing about the specific subjects. When you go to your next job, wherever that is, the company that you work for is going to have some kind of specialty, whatever it is. And there are a bazillion different specialties, even in our local area, many. So here's an example from my life story. When I started out, I was designing dump truck beds. So they were like this. And so that involved basically forming metal and welding metal and making it strong. Then I got another job at a rock crusher plant, and I spent a lot of years of my life doing this. So this is what you call heavy equipment design, and it's super fun. Got a lot of variety in it, and I got better and better at it over the years. But then that company went out of business, which can happen. And so I landed at a company that did store fixtures and trade show exhibits. Well, as you might imagine, that has almost nothing in common with heavy equipment design, and it has all different kinds of materials that you don't run into with machinery, different kinds of fasteners, just a myriad of fasteners. So that was a huge learning curve. And I tried to find a book about designing those, and there isn't one. Then that company went out of business. Not my fault, by the way. So that company went out of business, and I landed at a company that did onboard truck scales for heavy trucking. And my job there was the plastic packaging that goes around the electronics. Well, that's great, but I didn't know anything about plastic. So I had to learn just as fast as I could. And as you can see, these are just a few examples of the probably thousands of different specialties you might land in. So we could have a class on how to design X, but then you go to work for a company that builds Y and you don't know anything about that. So we need to back up and take a different approach. What you need to do is to learn how to think like a designer. Basically, how to think. What are the factors you need to consider? What will work? What won't work? And a key part of that is learning how to find information. You will find when you work as a designer that a huge part of your work is looking things up. And it might be technical data from a manufacturer who makes a certain part that you're going to use in your thing. There might be some other kinds of tables that you're looking up. It might be, like in my case, I had to find information about how does plastic molding work and how do you specify it. So learn how to think, learn how to find information, and then as much as you can, become familiar with a broad body of knowledge, which is what we're trying to do here in your college education. We can't possibly cover every single specialty that you'll run into, but if you know that there are certain things out there, like you know, okay, conveyors is a thing, plastic molding is a thing, here's where I find information about that. That will take you a long way. In other words, all of this learning how to think and how to find information and becoming generally familiar with a broad body of knowledge is what makes up being a college-educated person. So we are learning not just what are the factual details about how you do this or that. We're learning how would you think about how to do this or that, and how would you become better at it. Your goals for your future job are basically these. You want good thinking skills, which we develop over time as we talk about things. You, of course, need to be able to draw because your employer is going to want you to make drawings or models. So you want to build your drawing skills. And then as part of that broad understanding of the world, you want to understand generally how do things work, which we try to look at over the course of your college career. If you have these skills, you're going to be able to thrive wherever you land. I am sure of it. Now, one thing you might want to start doing as a designer is to just really keep your eyes and ears open, and when you're out there in the world, whenever you look at anything, a doorknob, a hinge, whatever it is, think to yourself, well, A, how does that work? And B, how did they make that? And just be open to thinking about that, and be kind of a filter feeder. As information comes across your awareness, gather it in and begin collecting. How are those things made? It would be a really great idea if you would start collecting this sort of stuff. And here's why. As we said, you don't know where you're going to land or what kind of specialty you're going to be in. But one of the things that can happen is all of a sudden your employer will say, let me see, okay, you're going to do, suddenly you're going to do a formed sheet metal toolbox to go on the back of a trailer. And so they say, here, draw one of these. And if you're like me, your reaction might be, I have no idea what those look like. And what works for a latch anyway? And what is the kind of hinge you should use? I have no idea. Or another example is belt guards or guards in general. I've seen so many drafters get tasked with making guards, and the first thing they do is just kind of stare like deer in the headlights. I have no idea what to do. So anyway, you don't have to design things from scratch. You can build on what has gone before you. And so if you keep files and photographs and whatever else you can collect and sort them by whatever category, then when your employer says, I'd like you to do a toolbox or I'd like you to do a belt guard, you're not starting with a blank piece of paper. You go look at and see, well, what do other people do? And you have a starting point. So I really recommend that. One more skill you're going to need in the workplace is this one. They pay you by the hour, of course, and so they're hoping that they get good value for their money, and that you can produce a number of drawings in a certain amount of time. How do we build speed? Practice, practice, practice. So to that end, in this class and next term as well, we are going to practice. We're going to continue making drawings and keeping our skills brushed up while we try to build some technical knowledge and some thinking skills. And let's go look at what our syllabus schedule looks like. If you open the schedule in your Moodle course, you'll see it is a spreadsheet sort of thing here. You're probably familiar with these. And as you look through this list of what topics we're covering, you notice, well, there's a variety. So we'll start out next time just thinking about, in the idea of learning how to think, we're going to just practice how do you think about figuring out quantities that you need, because that happens a lot. Then next week, we'll go back and review things that you already know about the dimensioning standards and the CAD standards, but it's been a long time. It's probably been at least 6 months since you've used them, and so we want to review those and get solid on those. And I know that up to now, somebody's given you a title block and you just start drawing, but what happens when you get to the job and you have to make your own title block? That can be a little bit daunting because there are a bunch of details to think about. So next week we are going to make our own title blocks, and I'm going to give you a partial drawing to start with, but then you can do the layers and the styles and so forth, and I'll walk through those with you. Then we'll do auxiliary views and sections and so on and so forth. This crankshaft adapter is a more advanced sort of drawing, so we'll spend a couple of days talking about that. Then we'll do some welded handrails made out of pipe, so we'll have to look up pipe fittings and pipe sizes in some tables. And we'll spend several days just giving ourselves time to do that. Then in, what is this, week 5, I think, we're going to look at how do you form metal and how do you figure out what sizes to put on your drawings in case you need to do that. And then sort of related to that, what if you have to do hoppers, those things made out of metal with slopey sides? Then from there to the end of the term, I think that's starting in week 6, we're going to essentially look at the second half of the ASME Y14.5 dimensioning and tolerancing standard. So we'll look in a great deal of detail at how to do tolerancing, how to put tolerances on a particular part. That's clearances and fits. It turns out if you have to make a certain part, you don't have to just guess what the tolerance should be. There are tables from ASME that tell you what range of tolerances to put on. So we'll get familiar with those tables. And we'll look at putting surface finish, which is another form of dimensioning. And then the last 3 weeks, we will look at something called geometric dimensioning and tolerancing, which makes up the majority of the Y14.5 tolerancing standard. And this is just an introduction to the basic ideas of geometric dimensioning and tolerancing, but it'll get you started and you'll have a good idea how that works. You will notice here we don't have any take-home midterm. We'll just be drawing, drawing, drawing. At the end we'll have a take-home final, but as is usually the case, it's not a big deal. So there you go. There's our plan for the term. We'll plan to turn things that will be due on Mondays, so you always know what day to shoot for. So there you go. I'm glad you're here, and I hope you have a great term.